We now discuss the solution of a problem from the section Matrices and Determinants. The problem is to count the number of matrices in a given context. This question has appeared in the Joint Entrance Examination Main held on 24th June 2022 in the second shift. The problem is, let S be the set consisting of the 2 by 2 matrices minus 1A 0B, first row minus 1A, second row 0B, where A, B belongs to the set consisting of natural numbers 1, 2, 3 up to 100, and T suffix n, Tn, is equal to the set of all A, capital A, belongs to S such that A power n into n plus 1 is the identity. Then the number of elements in the intersection n is equal to 1 to 100 of Tn is. We have the set of matrices 2 by 2 matrices given in this question, and Tn is the set of all those matrices A belongs to the above set S such that A power n into n plus 1 is equal to 1. We have to now count the number of elements in intersection Tn, where the intersection ranges from n is equal to 1 to 100. So we have to find the number of elements in this intersection. We have S is the set of all 2 by 2 matrices whose first row minus 1A, second row 0B, where AB belongs to the set of natural numbers 1, 2, 3 up to 100, and Tn is the set of all A belongs to S such that A power n into n plus 1 is equal to the 2 by 2 identity matrix, where n is a natural number. We first study T1, that is, we first study the situation when n is equal to 1. Now T1 will be put n is equal to 1 in this set of all A belongs to S such that A square, A to the power of 1 into 1 plus 1, that is 1 into 2, 2. A square is equal to identity. So that is A belongs to S, A must come from this, and A square is equal to identity means A belongs to S means A is of this type. A square, that multiplied by the same, is equal to identity 1001. Multiply, then you get, after multiplication, you will get a 2 by 2 matrix, 1 whose first row is 1 A times B minus 1, 0 B square, that is equal to identity 1001, equating the corresponding elements in the matrices. We get B square is equal to 1, and A times B minus 1 is 0, where A, B's are coming from the set of natural numbers 1, 2, 3 up to 100. Now B square is equal to 1 and B is coming from this set will imply B is equal to 1. When B is equal to 1, A times B minus 1 is 0, irrespective of what the value of A is. So this will imply B is equal to 1 and A belongs to, A can be any value from 1 to 100. So A belongs to the set consisting of 1, 2, 3 up to 100. So T1 will be the set of all those 2 by 2 matrices whose first row is minus 1, A, yes, 0, B is 1. B is 1, where A takes any value from 1 to 100. So how many matrices are there? As many as there are the elements A. So there are A can take 100 values. So therefore T1 has 100 matrices. Therefore order of T1, that is the number of elements in T1, is 100. Now we continue the discussion in the next slide. So we have Tn, n belongs to n. Now T1 we have, is equal to the set consisting of A belongs to S, A square is equal to identity. Note that for any natural number n belongs to n, n times n plus 1 is always an even natural number. So for any n belongs to n, n times n plus 1 is always an even natural number. So let us, when it is an even one, so n into n plus 1 by 2 is also a positive integer. So let that be m. M is equal to n into n plus 1 by 2, which is a natural number. Now A belongs to T1, means what? A square is equal to identity. Now raise both sides to the power of m. A square to the power of m is equal to I power m. That will imply A power 2m is equal to identity. So what is 2m? N into n plus 1. A power n into n plus 1 is equal to identity. That means A belongs to Tn. A belongs to Tn. So this in this what we have proved is every element of T1 is also an element of Tn for any n. So for every n belongs to n, this happens. So that means T1 is contained in Tn for all n belongs to n. So, intersection of n is equal to 1 to 100 Tn will be, that means T1 intersection T2 intersection T3 intersection T100. So in all these things T1 is contained in Tn for all n belongs to n. So therefore the intersection will give you the smallest set. So that will be the T1. So the intersection of n is equal to 1 to 100 Tn is equal to T1. So we answer the question now. The number of elements in the intersection Tn, n is equal to 1 to 100, is the order of the intersection of Tn, n is equal to 1 to 100. So the intersection of Tn, n is equal to 1 to 100 is T1. So this will be equal to order of T1. That will be equal to 100. That is our answer. And it is definitely a good question. And based on counting the number of matrices, matrices in this context. So I'm sure that you have understood the solution of this problem, and I wish you all the best. Thank you.